Hey everybody, Brian here from quantlabs.net. Just wanted to go over my first attempt at kind of like a problem solving solution. This comes from a combination of sources that I'll post or that are part of the comments in this little program in the C++ here. Just so everybody knows, this is my second demo in C++ using CLion on Ubuntu Linux. Okay, so this is what we're doing. Is at the end here, as you can see, we're going to have two positions for hedging, and we're going to assume short hedging. Now, there's going to be two contracts. The first one is typically your cash position, and your second one will be the actual future. And what it does is it'll ask for some criteria. It'll give you a futures difference, or a difference between the two future positions, the cash positions, also the net outcome between the two. So the idea here is I'm going to enter in a timestamp. I'm going to show you how that works, and then both the amount for the cash and futures position, and again, that's the first one, and then the actual for date on the second contract. So there's two contracts we're entering in. Timestamp again for that period or for that contract, and then we enter in the cash amount, the futures amount, and then we also have to include the number of contracts we're going to try to figure out, as well as the number of units for the commodity. Now, the other thing is I need to highlight this will only work on agriculture, basically commodities like agriculture and energy. And I believe it may work on metals as well. All right, so the other thing is we need to calculate the basis, which is basically the difference between the future prices and the cash prices. And you know, it's a simple but knowing me, I probably world famous for messing stuff up. So if you see something wrong, let me know. I won't be offended. All right. So what I'm doing here in this piece of code is I've got my cash. The two contracts, cash 1, cash 2, for those two positions, and then the futures for contract 1 and 2. And this really doesn't really is never inputted, but this will calculate. As I said, I already hinted at what the difference is. I'll show you that again in a minute. We also have our brokerage fee for the total transaction cost, the difference between the cash and the futures, and then our final net outcome. As I said, we're going to use our total units of the commodity and number of contracts. Now, theoretically, we could dynamically calculate this, but I think what would happen is you just make this a generic function, and then you can run another little script, a program that will call this and just try to optimize, you know, how many contracts should you set based upon your available capital, so on and so forth, so you can optimize the optimal settings that you would put in for your cash and futures positions based on your outlook on your forward contract. As well as I've also done a demo as well on calculating your hedging ratio based on all this information as well. This will be all part of a bigger plan of a better system that will calculate all this stuff. I'm just showing you the basic mechanics behind it. Again, I'm not saying it's 100% correct. If it's wrong, let me know. All right, so so what we have here is basically two functions here. I'm just going to the main first. Now, with C++ and how wonky it can be, you're going to get functions like this and like this, that will be very generic, used throughout a system. Again, these are not optimal, I don't think, but you typically, if you're trying to get a system into, let's say, a higher frequency trading system, typically you want, obviously, as fast as possible. So you're really going to be trying to reduce the amount of dependencies you have. So a good example of that is Boost, and probably, I think STL is okay, but definitely Boost is a library. Whereas that can be pretty inflated, and that can definitely might be quite inefficient code. It's convenient to work with, but it's more going to be inefficient when you run it in a HFT kind of environment. So I wouldn't recommend that in the long run. But when you're starting out, definitely use those libraries if you need to. But my mindset right now is just to keep it as self-contained as possible, meaning no dependencies, or as few as possible. All right, so knowing that, what I've got here is I got some inputs. We got, as you can see here in the comment, this is how I try to demonstrate my code. I usually put in my breadcrumb sources of where I get this piece of code from. I also try to keep it consistent as possible. But this piece of code is kind of important because it will showcase how to convert, let's say, a timestamp string representation to an actual low-level structure in C++ that you can use efficiently, kind of like C-like, I guess you could say. So in this case, I'm just going to talk about this little commented code out here. Here, if you go to this link, you'll get the demonstration code, and it's better explained, but I'll do it in a nutshell. What we have here is we're using this generic string p time, where you have a string, and you're going to convert it into this generic time structure. And obviously you'll have those broken out by second, minute, hour, month, year, so on. So that's what we're doing. Now, as I said earlier about generic functions, this one here, this input int and input double are good examples of that, of the approach I just talked about. So we have here two separate functions. The first one is the input double. So what it does is it's just going to use a string line, a double as well. And I've also got this little val here just for convenient purposes. I'm sure there's a better way of doing this, but I haven't really honestly looked at C++ in a while. So these are things that you can be cognizant of, but this is not really all that efficient. But for now, it's fine. Again, it's that convenience versus efficiency. But right now it's just quick and dirty. So what we're doing here in this function is we get the input from the console, feed it into this line variable, which is really a double, I believe. Or no, it's a string, sorry. And then we're using this streamer, I believe, from, which one is it? SS stream, this one right here. Now, with that in mind, that's all cool, I guess. So we've got that. Now, here's a little trick here. What we're doing here is we have, if in our line we find the underscore and it's not equal to the end position, the size of the string, then we know it's not an integer. Okay, so it's a double, because usually a double will contain a decimal. I'm going to have to show you some tricks here as we do the input. So we do this wonky little conversion to a double, and then that gets converted to a double based out of what's in the string, and then from there we just pass in this value, which is a generic return. Another way of doing it is just put a return a double if you're worried about that, and if this condition isn't met, meaning it's an integer, then just return a -1, meaning it's an error. So back to this return, a lot of people like to have one return in each function. personally, me, I would not really care, but I could just put return a double and then return -1. But everybody's different, I guess. Now, this next function here called input integer is the same idea as the double. Where's my function? Let's see. Yeah, there we go. So it's the same idea. The only difference is we're just reversing everything here. So as you can see here in this condition, it's a not equal to the same. And if it is equal to the same, even though you may have a decimal, then we know it's an integer. Everything's the same. So in this case here, we've got all our strings, the output. We input in the of an integer. Let's see, and then we also have the double, the integers. We do that all the way down to here. This is our first calculation. So what we're asking for is here's the number of contracts, timestamp for the first one. This is contract 1, as you can see here. We enter in the first cash position, futures position. That's the current, and then from there we can calculate the basis. Okay. The next one is the C out of contract 2. Cash, enter in the timestamp of the second contract. Example like what I talked about earlier about converting a string to that time structure. Like, you know, in these comments here, this is a similar idea. But just a demonstration how you can convert a string to a convenient time structure in C++. Okay, so we have that. Again, these calculations, I hope they're kind of they're okay. Now, again, remember I talked about the references. There's a series here. There's some notes here. I assume that this is a short hedge only. So I'm getting all these calculations from various sources. In this case, we're doing, so hold on, we missed one. So we got our basis. We calculate, that's a basis for the second contract. We calculate our basis for the first contract here. So we're down to here. We've got a second basis. Don't forget we need the face value of the contract, the future, and also total number of units that we're going to sell on. And then we're going to calculate our futures difference between the second and the second contract, which is the forward contract, minus what we paid for, times the face value, times the number of contracts. Now again, this can be called, and this is where we optimize. So if we have a number of units of face value, I don't know, let's say we've got something that has a face value of $100,000, whatever that commodity might be, and then we want to put a position on of 150,000 units. We determine a number of contracts based on that, and we can have this function and build it out in a way where we can optimally say, no, get 2 contracts versus 3 contracts. So in the futures difference, again, is from the second contract forward minus the current price we paid times the face value times the number of contracts. We also have our brokerage fee for this trade, and then we have to calculate our cash difference. So we do that. Yeah, cash difference is the second contract of the futures forward minus the what we paid times the face value times the brokerage minus the brokerage fee. And then we also have to calculate our net income of the future difference between minus the futures difference minus the cash difference. and then of course we output everything. Now, this is all determined by if we're going to forward, so if we're going to short or not, and there's usually 3 factors that come into play. We got to worry about the basis as a factor that can hinder our trading on the future. We also need to worry about a number of contracts, because that can, you can typically increase your profit based upon the number of contracts you place. Now, to get a better idea of that, just watch those UCS Davis, UC Davis futures and options course I've gone on about. One with Colin Carter explains all this. So that's the second factor, and of course the other factor that will affect a profit and loss is the forward futures price and what it actually ends up being. So that has obviously an impact. So with that in mind, we get our output, and again, we can just call this little function, just make it a little cleaner, but I just want to demonstrate hopefully how this works when it comes to hedging and hedging out your risk and being able to determine if it's profitable or not based on our basis, our futures market price, as well as the number of contracts. So again, depending upon if our basis widens or not, that can be profitable, and the magnitude can also be driven by the number of contracts. So if you want me to see this run, I can definitely do that. And you can just run it. Number of contracts, let's say 3. Timestamp. Now, just so people know, this is a typical timestamp where I'm referring to. So it can be, this is really not all that important at this point, but it will be for future needs in upcoming demos and calculations. So let's say our cash price is at 70 cents for the first contract, second contract at 78 cents on the future. The cash price goes down on the forward looking. Cash price of 0.6. Futures market at 0.89. As you can see here in the second timestamp, again, this is for now not important, so I just put in bogus stuff. Face value, I don't know, let's say it's 40,000. Okay, now this is really important. As you can see here, it's very critical that you see I enter in this period. This is a whole number, but it's being treated as a double. Here, I just wanted people, this kind of messed me up for a little bit. But you see that is the face value right here, which is a double, right? So in order for these little functions to work, you need to enter in the period. So let's put 0.0 and total number of units. So I'll say 100,000, 0.0, and broker fee $250. And here's our output. So our basis on the first contract, basis on the second contract. Here's a futures difference, here's a cash difference. So overall, we have a net outcome of 14,401. Okay, so hopefully I'll help you out. Just give you an idea. If you see any errors in that, please let me know via comment on my YouTube channel or maybe my Facebook. And I'll talk to you soon. Later.